Hello, welcome. Calculus 2, Chapter 10. We started talking about some conic sections. I wanted to say something else about ellipses. I think I took you through some work with ellipse, but a few more things to say. This is the geometric definition of an ellipse, which I like. I gave you the geometric definition of a parabola, I also like. Here it is, the set of points, x, y, the sum of whose distances from two distinct fixed points, called the foci, is constant. It's kind of hard to say and maybe hard to understand, but let me help you. If I have two distinct fixed points that are the foci, then the set of points that are on the ellipse are the set of points whose sum of the distances from those foci remains constant. So one way you can use this to construct an ellipse, and you might have heard this before, is you get these two fixed points, you tie like a loose string to them. You get a pencil or something, and I mean I did this in the ground before. You pull the pencil, you pull it tight so that that distance and that distance is tight. You pull the string tight, and then you trace your way around. And as you trace around, the sum of those two distances remains constant. The sum of those two distances remains constant as you trace around and find the set of points on the ellipse. So you can actually construct one in the ground on a piece of paper if you have some way to do that. Cool. Remember we talked about the eccentricity of an ellipse, and we talked about the eccentricity is always a number between 0 and 1. By the way, it's the ratio of C to A. One more time. A is half the major axis, and C is the distance to the foci. So it's a ratio of C to A. Is measurement of how elliptical it is. And when C is closer to the center, that ratio is smaller. It's closer to 0, and it's more circular. When C is further out toward the end of the ellipse, the vertex of the ellipse, then this ratio is closer to 1, and it's way more elongated, more elliptical. What I wanted to point out was, we've heard that I suppose, that here's the sun, and that the planets travel around the sun in elliptical orbits. The sun lives at a foci. The sun is not the center of the ellipse. The sun is one of the foci of the ellipse. And then the planets revolve around the sun in these elliptical orbits. And I heard that. I've always heard that. What I learned here in this book, and I've known it for a while, is, boy, those elliptical orbits sure are circular. The eccentricity of Earth is 0.0167. That's Earth's elliptical orbit. I mean, very circular. Venus is 0.0068. The most elliptical one is Mercury. Mercury is 0.2056. So I think this is interesting. So yeah, they're ellipses. Yes, they are not circles, they are ellipses, but dang, they are circular. They are very circular. And what that means is the center of the sun is at a foci. The center of the sun is at a foci. The center of the ellipse is like right next to it. It's in the interior of the sun, but it's next to the center of the sun is the center of the ellipse. The sun's center is at a foci. I can see it clearly here, but these elliptical orbits are quite circular. So I think that's interesting. I want to do a problem out of the book. What I did the other day was I gave you an ellipse. We completed the square. We found everything, and we and we graphed it and we found the foci. I want to do a backwards problem, so this comes out of the book. I'm going to get rid of this information. This is where we have to find the equation of the ellipse, find the equation of the ellipse, and they give me a little bit of information. So I like these kind of questions. This particular problem is in our book. It's number Number 32 says the foci, this is kind of easy, the foci are at 0 plus or minus 9, and it says the major axis length is 22. The major axis length is 22. So with that information, I should be able to find the equation of the ellipse. The equation of the ellipse. Let's see. A picture might help me think this through. Let's see, the foci are at 0 plus, okay, 0, 9, 9, that's one of the foci, and 0, negative 9 is the other foci. Okay, all right. And then the major axis is length 22. Now I know that the major axis runs through the foci, and if it's got a length of 22, and by the way, I guess the center is 0, 0, that's nice. 0, 0 is the center of my ellipse. By the way, that makes me write, instead of x minus h squared, well, my h and my k are 0, so I'm going to write x squared and y squared. I also know that ellipse is plus. I also know it equals 1. My job is to find what I called a squared and b squared here, these numbers a squared and b squared. Let's see. Now the major axis is length 22. So if it's length 22, then it goes up here to 11 and down to negative 11. Okay. All right, well then I just learned that a is 11. A is 11. The length of the major axis is always 2a, so a is 11. And by the way, from the center to the foci is c, so c is 9. Now, I think in one of my examples I wrote a squared underneath here, but that was an ellipse elongated horizontally. So when this ellipse, when the major axis is running vertically, we put the a squared, we put the larger number underneath the y squared. So the a squared goes under here, that's 121. My job is to find this b squared here. This is b squared. And, you know, this is the distance b. But here's the key. For an ellipse, I need to remember that a squared minus b squared is c squared. That's just true for an ellipse. A squared minus b squared is c squared. Always true. Usually you have a and b and you're looking for c, but in this case, I have a and c. I'm going to look for b. Here we go. A squared is 121 minus b squared. C squared is 81. Okay, I'm going to add the b squared over there and subtract the 81 here. So b squared is 40. I could tell you what b is, but the truth is, I actually want b squared for this formula, so I want to put 40 right here, and we're done. We did what they wanted. We found the equation of the ellipse. Drawing pictures, knowing some relationships, some equations helps you do these problems. I like these backwards problems. That was kind of an easy one. All right, good luck. Keep trying to do some homework.